Tell me about a time your solution did not work as expected. Introduction. This is an important behavioral interview question for software developers. Interviewers ask this question to understand how you handle failure, how you take accountability, how you respond when a fix does not work, how you investigate unexpected results, how you communicate with the team, how you improve your approach, how you prevent the same mistake from happening again. This question is especially important for junior software developers, Java developers, backend developers, full-stack developers, senior software developers, production support developers, team leads. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to see how you reacted when the first solution did not work. Question. Tell me about a time your solution did not work as expected. Example 1. Caching solution caused stale data situation. In one application, an API was slow because it repeatedly fetched the same reference data from the database. I implemented caching to improve performance. The initial solution improved response time, but after deployment, users reported that some updated values were not appearing immediately. Task. I was responsible for investigating why the caching solution caused stale data and correcting the design without losing the performance improvement. Action. I first reviewed the cache configuration, expiration time, and the business rules around how often the data changed. I realized that I had treated the data as mostly static, but some values could be updated by admins during business hours. The cache expiration time was too long for that use case. I discussed the issue with the product owner and confirmed which data needed near real-time updates and which data could be cached longer. Then I updated the caching strategy. I changed the design to use shorter TTL for frequently updated data, short, longer TTL for stable reference data, cache eviction after admin updates, short, fallback to database when cache missed, short, monitoring for cache hit rate and stale data reports. I also added test cases for update scenarios to verify that users saw the latest values after admin changes. Result. The stale data issue was resolved. The API still performed better than before because low-risk reference data remained cached. This experience taught me that caching should always consider data freshness, not only response time. Why this answer works. This answer is strong because it shows accountability, performance thinking, cache invalidation awareness, business rule validation, correction of design, learning from the issue. Example 2. Query optimization changed report results situation. In one project, a reporting API was slow, so I optimized the SQL query by removing unnecessary joins and simplifying filters. The optimized query was faster, but QA found that some report totals did not match the original output. Task. I was responsible for finding why the optimized solution changed the result and fixing it without losing the performance improvement. Action. I first compared the old query output and the new query output using the same test data. Then I checked which records were missing or counted differently. After investigation, I found that one join I removed looked unnecessary, but it was actually filtering out inactive records indirectly. By removing the join, the optimized query included some records that should not have been counted. I corrected the query by adding an explicit active status filter instead of depending on the join side effect. Then I validated the report using multiple test scenarios: active records, inactive records, date range filters, month-end records, large data volume, old query versus new query comparison. I also documented the business rule so future developers would understand why the filter was required. Result. The corrected query produced accurate report totals and still performed much faster than the original query. The issue helped the team improve our query optimization review process by validating both performance and correctness. Why this answer works. This answer is good because it shows SQL troubleshooting, careful validation, ownership of mistake, preserving correctness, improving review process. Example 3. Retry logic created duplicate processing situation. In one backend service, we added retry logic for failed downstream API calls. The goal was to improve reliability when the downstream service was temporarily unavailable. The solution worked for temporary failures, but later we noticed duplicate updates in some retry scenarios. Task. I was responsible for identifying why the retry solution created duplicates and making the flow safe. Action. I reviewed the logs, retry attempts, downstream API responses, and database records. I found that some requests timed out after the downstream system had already processed them successfully. Because our service did not receive the success response, it retried the same request. That caused the downstream update to happen more than once. I realized that retry logic alone was not enough. The operation also needed idempotency. I updated the design to include a unique request ID for each operation. Before applying an update, the downstream flow checked whether the request ID had already been processed. I also separated error handling into check retryable errors, check non-retryable errors, check timeout scenarios, duplicate request handling, check dead letter or manual review cases. I added monitoring for duplicate attempts and retry counts. Result. Duplicate processing stopped. The retry logic became safer and more reliable. This experience taught me that retries should be designed together with idempotency, especially in distributed systems. Why this answer works. This answer is strong for backend interviews because it shows, distributed system thinking, retry design, idempotency, learning from unexpected behavior, reliability improvement. Example 4. Front-end fix did not handle slow network situation. In one full-stack project, users reported that clicking the save button multiple times caused duplicate submissions. I fixed the issue by disabling the save button after the first click. The solution worked in normal testing, but during slow network conditions, some users still saw confusing behavior. Task. I was responsible for improving the solution so the page handled slow networks and API failures correctly. Action. I reproduced the issue using browser developer tools and simulated slow network conditions. I found that the button was disabled after clicking, but the page did not clearly show loading progress. If the request failed, the button sometimes remained disabled, and users did not know what happened. I updated the solution to handle the full save lifecycle. The improved flow included check disable button during submission, check show loading indicator, check show success message after save, check show error message on failure, check re-enable button after failure, check prevent duplicate requests, check refresh latest data after success. I tested the change with check successful save, failed save, slow network, repeated clicks, page refresh, validation errors. Result. The save flow became more reliable and user-friendly. Duplicate submissions were prevented, and users received clear feedback during slow or failed requests. This taught me to test UI fixes under real user conditions, not just normal happy path scenarios. Why this answer works. This answer is good for full-stack interviews because it shows user experience awareness, front-end debugging, failure scenario testing, ownership, improving an incomplete solution. Example 5. Batch job fix failed for edge cases situation. A nightly batch job was failing because some input records had unexpected formatting. I updated the parser to handle the new format. The fix worked for the sample file we tested, but another batch run failed later because there were additional legacy formats we had not considered. Task. I was responsible for improving the parser so it could handle expected variations safely and report truly invalid records clearly. Action. I reviewed multiple historical input files instead of only the failed file. I compared the different record formats and grouped them into known valid patterns and invalid patterns. Then I updated the parser to support all approved legacy formats. I also added validation logic so unsupported formats would not crash the entire job. Instead, invalid records were captured in an error report for business review. I improved the batch job by adding test files for each supported format, record-level validation, skip logic for invalid records, clear error messages, restartability testing. Result: the batch job became stable across different input files. Valid legacy records were processed successfully, and invalid records were reported clearly. This experience taught me to test fixes against broader historical data, especially in batch systems. Why this answer works. This answer is strong because it shows what it shows. Edge case analysis, batch processing knowledge, learning from incomplete fix, better validation, improved reliability. Example 6. Security rule fix blocked another flow situation. In one application, we fixed a security issue by tightening access rules for certain APIs. The fix worked for the original issue, but later QA found that another valid user flow was blocked. Task: I was responsible for reviewing the security rule and correcting it without reopening the original security risk. Action: I first reviewed the original security issue and the new QA reported failure. I compared both flows and checked which roles and endpoints were involved. I found that the rule was too broad. It blocked access to a shared endpoint used by multiple valid flows. Instead of applying one broad rule, I changed the configuration to use more specific endpoint-level authorization. I also reviewed all related endpoints to understand shared usage. Then I added tests for CUC, original unauthorized scenario, CUC, valid user flow, CUC, admin flow, normal user flow, CUC, missing token, CUC, invalid token, CUC, forbidden access. I reviewed the final change with QA and another developer before release. Result: the original security issue remained fixed. The valid user flow started working again. The additional access tests improved confidence in future security changes. This experience taught me to review shared endpoint usage before changing security rules. Why this answer works. This answer is good because it shows security awareness, impact analysis, correcting an overbroad fix, regression testing, careful risk management. Example 7. Performance fix, increased memory usage, situation. An API was slow because it made repeated database calls. I improved performance by loading related data once and reusing it during processing. The API response time improved, but memory usage increased more than expected during high-volume requests. Task: I was responsible for adjusting the solution so the API improved performance without creating memory pressure. Action: I reviewed memory metrics and tested the API with larger data volumes. I found that the solution loaded too much related data into memory at once. The approach worked for small requests but did not scale well for larger requests. I changed the design to process data in smaller chunks instead of loading everything together. I also added pagination and limited the amount of data held in memory at one time. The improved solution included chunk-based processing, pagination, smaller in-memory data structures, avoiding unnecessary object creation, memory monitoring, performance testing with large data volume. The API maintained improved response time while memory usage became stable. The solution became safer for high-volume requests. This experience taught me to test performance improvements against realistic data sizes, not only small test cases. Why this answer works. This answer is strong because it shows CUT performance trade-off awareness, memory analysis, scalable design improvement, testing under realistic load, CUT accountability. Example 8. Deployment change worked in test but failed in production. Situation: we updated configuration for a service deployment in the test environment. The change worked successfully in test, but during production deployment, the service failed to start. Task: I was responsible for helping identify why the solution worked in test but failed in production and correcting the deployment approach. Action. I compared the test and production configurations. I checked: environment variables, secret names, database connection settings, feature flags, startup logs, health check configuration. I found that production used a different secret name than test. The application expected the test style secret name, so it failed at startup in production. To fix the immediate issue, we corrected the production secret mapping and restarted the service. Then I improved the deployment process by adding startup validation with clear error messages for missing configuration. I also updated the deployment checklist to verify required secrets before deployment. Result: the service started successfully after the configuration fix. Future deployment issues became easier to detect because missing configuration produced clear startup errors. This experience taught me to compare environment-specific configuration carefully before production releases. Why this answer works. This answer is strong because it shows key environment troubleshooting, compliance learning, production safety, checklist improvement, prevention mindset. Best short answer version. If you need a short interview answer, you can say, in one project, I added caching to improve the performance of a slow API. The API response time improved, but after deployment, users reported that some updated values were not appearing immediately. I was responsible for investigating why the solution did not work as expected and correcting it. I reviewed the cache configuration and realized that I had treated the data as mostly static, but some values could be updated by admins during business hours. The cache expiration time was too long for that use case. I discussed the data freshness requirement with the product owner and updated the caching strategy. I used a shorter TTL for frequently updated data, kept longer caching only for stable reference data, and added cache eviction after admin updates. As a result, the stale data issue was resolved while keeping most of the performance benefit. This taught me to consider both performance and data freshness when designing caching solutions. Common mistakes to avoid. 1. Blaming others. Bad answer. The requirement was not clear, so my solution failed. Better answer. I should have clarified the data freshness requirement earlier, so I corrected the design and added better validation. 2. Pretending the solution was fine. Bad answer. My solution worked, but users misunderstood it. Better answer. The solution improved one area, but created a new issue, so I investigated and adjusted the design. 3. Not showing learning. Bad answer. I fixed it and moved on. Better answer. This taught me to test performance fixes with realistic data and edge cases. 4. No prevention step. Bad answer. I changed the code again. Better answer. I added tests, monitoring, and documentation to prevent similar issues. 5. Choosing a serious failure without recovery. Avoid examples where the outcome sounds uncontrolled or careless. Choose an example where you took responsibility and improved the solution. Best practices for answering this question. Checklings. Use the STAR method. Be honest but professional. Choose an example with a good recovery. Explain what did not work. Take accountability. Show how you investigated. Explain how you corrected the solution. Mention what you learned. Mention prevention steps. End with a positive result. What interviewers are looking for. Interviewers want to see whether you can admit when something did not work. Stay calm and professional. Investigate unexpected outcomes. Take ownership. Adjust your approach. Communicate clearly. Learn from mistakes. Improve system quality. Prevent repeat issues. For senior roles, they also want to see: check risk management, trade-off awareness, production thinking, accountability, decision-making maturity, mentoring or process improvement. Strong words to use in your answer. You can use words like investigated, reassessed, corrected, adjusted, validated, learned, improved, monitored, refined, relished, communicated, prevented, documented. Example: I reassessed the original design, identified why it did not work for that scenario, adjusted the solution, validated it with additional test cases, and documented the learning for the team. Good example topics you can use. Depending on your experience, you can talk about caching caused stale data, query optimization changed results, retry logic caused duplicates, front-end fix failed under slow network, batch job fix missed edge cases, security rule blocked valid flow, performance fix increased memory usage, deployment change failed in production, API validation fix missed, optional fields, check, pagination fix missed sorting edge case, check, configuration change worked in test but failed elsewhere. Final summary. Tell me about a time your solution did not work as expected is an important interview question because it tests accountability and learning ability. The best answer should include what problem you were solving, what solution you implemented, what did not work as expected, how you investigated, how you corrected it, what result you achieved, what you learned, how you prevented recurrence. Good examples include caching, stale data, SQL optimization, changing report results, retry logic, creating duplicates, front-end fix, failing under slow network, batch parser, missing edge cases, security rule, blocking valid access, performance fix, increasing memory usage, deployment configuration issue. The strongest answers show honesty, ownership, correction, learning, and prevention.